All right, so here's our last possible case for adding and subtracting rational expressions. And in this case, it gets a little bit tricky because one of our denominators, the x squared minus 4 in this case, is something that is factorable. So I actually can't compare what's missing and what's present in both of my problems. So again, let's go back to something that we looked at earlier in a previous video, right, where we actually took the denominator 6 and we broke it up into 3 times 2. And we took the 4 and we broke it up into 2 times 2 so that we could compare the parts and see what was missing and what we needed to bring into each fraction to make them common. Right? So we're going to go back to our problem now, and we're going to say that x squared minus 4 in factored form, we're going to leave the first one alone, right, as x minus 2. That doesn't factor at all, but this x squared minus 4 is really x plus 2 and x minus 2. And then the top will leave as negative 8. Okay, so now when I look at these, I can compare them and say, all right, the left one has an x minus 2. The right one already has that, so I don't need to change that one. So let's compare the other way. The right-hand fraction has an x plus 2, but the left fraction does not have an x plus 2. So I need to change the second fraction, or the first fraction only, by saying I have the x minus 2 there. Okay, let's bring in a brand new x plus 2 so that it matches the fraction on the right. So I actually, in this case, don't need to change the second fraction at all, but I need to change the first one so that it can get that one factor, that x plus 2 that was missing. So in this case, I had the x present in the numerator, and if I compare my original problem to my new one, it looks like I brought in a brand new x plus 2. So I'm going to make sure that that shows up on the top. And again, I got a negative 8 over here. Let's bring that in. Okay, so let's multiply this out. That's x squared plus 2x. Okay, and I still again have that common denominator, x plus 2x minus 2. Okay, and then over here I have a negative 8, which we didn't change this one at all, so it looks the same as it has, except it's in factored form, right? And so now I'm going to add these together. This looks like x squared plus 2x minus 8. Right? There's really no other way to put this together but just to tack that negative 8 onto the end, and I get this expression, x squared plus 2x minus 8 over my common denominator. Remember, when you put together your denominators, there's no need to change anything. So now I'm going to look at this and say, all right, I got them together, I added the fractions. Now I need to check and see if there's any way to simplify the fractions, right? So I'm going to come over here, I'm going to head in this direction in all this white space, and it looks like this does factor. X squared plus 2x minus 8 is the same as x minus 4, right? I'm sorry, x plus 4 and x minus 2. Okay? If I add together 4 and negative 2, I do get 2, and if I multiply these together, I do get negative 8, so that works. Okay? And my denominator is x plus 2 and x minus 2, and I get some canceling happening. So my final answer for this one in simplest form is going to be the x plus 4 in the numerator, okay, and the x plus 2 in the denominator. Right? X cannot be equal to 2 and negative 2 as my domain restrictions, right? But you get the idea here. We actually had to change or factor our expressions so that we could change the denominators and only bring in the new things that we want. It's not entirely obvious taking a look at this expression at the beginning that this x minus 2 turns into x squared minus 4 in any way, right? We actually need to look at the parts in order to figure out what's there, right? So let's take a look at another example that is a little bit more challenging, okay? So same basic idea. I'm going to factor both of my denominators. In this case, I'm going to say that the first one factors into x minus 9 and x plus 3. I didn't change the denominator or the numerator yet. I'm just factoring, okay? This one turns into x plus 9 and x minus 9 with that negative 8. Okay? And so we need to do a comparison now. So I'm going to look at the first one and say, is there anything that's present in the second one that is missing from my first one? So let's take a look. I'm just rewriting the ones that are there. Nothing's going to disappear. We're just going to add in new factors. So I'm going to look at this one and say, okay, I have an x minus 9. Yep, x minus 9 over there. So that one's good. I have the x plus 3. Okay. In this one, it looks like I have an x plus 9 that's not over here. So let's bring that in. So that's going to be new. So I'm going to bring in an x plus 9. If there's an x plus 9 in the right-hand fraction, there needs to be an x plus 9 in the left-hand fraction as well. So that means that my numerator is going to take a brand new factor, and that's the x plus 9. Okay, so now I'm going to do the same thing with the second fraction, right? So again, let me change colors. So I had the x plus 9 and the x minus 9. And now I'm going to look back and say, okay, there's x plus 9 and x minus 9. But it looks like this x plus 3 is in the first one, but not in the second one. So we're going to actually change that and say, let's bring in a brand new x plus 3. And then my numerator is going to be that negative 8, also times the x plus 3. So let's move it up and let's multiply. So now I'm going to say 10x times 9, right? So that's 10x plus 90, right? My denominator is all three of these factors. And however we write it, we can write it x plus 9, x minus 9. Doesn't matter. I'm going to leave it just like we have it. Okay? 3 factors. Okay? Same thing over here. This is negative 8x minus 24 over, and again, x plus 9. I'll make them match, so I'm going to switch the x plus 3 to the middle, and an x plus 9, or an x minus 9, right? So just make sure they're the same, right? That they have the same parts. It doesn't matter what order we put them in. So now I can combine. I have common denominators. All 3 of those factors on the bottom of the left-hand one match the denominator on the other one. So let's put these together. This looks like 10x plus negative 8x. That's 2x. 90 plus negative 24 is the same as 90 minus 24, which is a positive 66, right? And now I'm going to put that over x minus 9, x plus 3, okay, and x plus 9. My 3 factors in the denominator. Okay, and I'm going to look at this and say, all right, 2 is common, so I can check. That's really just 2x plus 33, though. And that's really not going to cancel with anything on the bottom, so I'm done, right? So this one definitely required a lot more work. We had to factor, okay? We had to find out what was missing in each of the denominators and make sure that we completed the common denominator. And then once we have the common denominator, you can add or subtract as you normally would.